Hey coding words. So basically in today's GFG POTD we have a problem, next greater element in circular array, and it is a medium level problem, and it is also really very much important problem as it is like asked in really very in very decent companies like Flipkart, Amazon, Microsoft. Okay, so first of all we are going to try to read this problem first. Okay, so here it will be like given a circular integer array R. The task is to determine the next greater element, that means NGE. NG is like basically stands for next greater element, which we have to like return, okay, for each element in the array. Okay, and the second paragraph here is like the next greater element of the array is the first that is greater than array of I when traversing circularly. If no such element exists, return -1 for that position. Okay, so what is the circular property here? Explaining, since the array is circular, after reaching the last element, the search continues from the beginning until we have looked at all the element once. Okay, so let's try to understand this example here. So basically here in the array, or here in the questions, we have an array that are like arranged in the circular fashion, and we have to like determine which of the element is like greater element for the current indices. Like for example, if I'm talking about for while traversing inside the array, if I'm taking the example of this element which is like 1, so for 1 which element is greater, so it will be like 3, okay, because it is like next to it. Okay, then for 3 we actually getting 4, which is the greater element, okay, for 3. Then for 2, no, for 2 we actually getting 4, but for 4 there's no any further element here, so we have to return -1. Okay, and but before that returning -1, we have to also check it separately that whether there any extra element which may be like appear previously to 4, which may be like greater than 4, but it is not present here, so we have to return -1. Similarly, if I'm talking about the example second, here we have like 0 2 3 1 1. So for 0 here, the next element which is the greater element for 0 is like 2, and for 2 it will be like 3. For 3 there is like no any other element which is like greater than 3, so we have to return -1. Now for this one, now we have to again traverse this array, like we as I've already told that this is like in the circular fashion. So again we check, so for 1 we actually getting 2, and for this one again we actually getting 2. So this is the thing. Okay, so we have to solve this problem with a constant error of size which must be like greater than or equal to 1 and less than 10 to the power 5, and here the expected complexities for solving this problem is like time complexity is like order of n, and outside space is like order of n, and this is like asked in the questions like Flipkart, Amazon, Microsoft, and this is based on data structures and stack completely. Okay, so we have to solve this one by using stack here. Okay, so how we can solve this by using a stack? See, if we are not going to solve by using a stack approach, or no, it is like important to solve this one by using stack. So the first approach here is that we have to traverse our array for 2 times, let's say 2 cross n. Okay, so the time complexity will be more, so here we have to solve this one by using stack. So what I'm saying here, so first of all we have to understand this one by taking the first example. I am explaining here what is the basic approach. So yeah, here is our question, which is the example number 1, where we have an array like 1 3 2 and 4. So what is my approach? I am going to solve this one by using the stack, and going to find all about next greater element. So for that, the first thing is that what I am doing, I am going to traverse. Okay, so here first of all I am going to traverse from the back side. Okay, that means from the last indices, and while traversing it I have to also store it inside the stack. So I have to also create a stack of the same size as the size of array. Okay, and then after that we have to simply store all the elements in the same way. Then after that I have to check the condition which of the element is like greater element or which is not for the next greatest element. If we find it, we simply take it. Okay, so let's try to understand it by using code. So here what we have to do, here first of all, here int n is equal to, here to define the size of an array. Okay, so for the first example here the size of array is like 4. Okay, And then after that, here we have to create a vector. Okay, that means here we have to create a vector where we have to return our result. Okay, so let's say I'm creating a vector, and as we know about vectors also, we can set a collections of items of same data types which are stored in contiguous memory locations, but here we have some operations by which we can perform, by which we can able to resize our account or need. Okay, so here vector of int, and let's say I'm defining the vectors int, and initially here what I'm doing here, I have to also create a vector of same size as the size of an array, and initially I have to fill with -1 value. Okay, that means currently in the first state my stack is currently having the size of an array, and it is filled with -1. Then after that I have to create a stack, okay, of also integer type, as we have to store this type of value. That means here in the stack we have to store the next greatest element in the circular array. So for that, what we have to do here, we have to define stack as st. Now what I have sent here, so I have already said that here the approach is, here I'm going to traverse it from back. So I is equal to n minus 1, and then I is greater than or equal to 0, and then I minus minus. So in the first step, what I'm going to do, I'm going to do st dot push. Okay, that means inserting all the elements inside the stack. So here array of I. Okay, now as I've already told here in the example here, so like in this way, this is my array, and I'm traversing it like in from back, like 4 2 3 and 1, and similarly I have to also like push it into the stack. So I'm getting this type of order like 1 3 2 and 4. Now we have to check for the next greatest element. Okay, so from here now we need to check for the next greater element. Okay, so how we can do, again we have to traverse it from back and check the condition. So for int I is equal to, again we have to traverse it from back, that means I n minus 1, and then I is greater than or equal to 0, then I minus minus, and then after that again here what we have to do, here we have to check the condition. So here we have to do while loop. That means if my stack is not empty, which is really not empty. Okay, if a stack is not empty, and second condition will be like, here we can say that if a stack is not empty and array of I, that means this particular index. Okay, that means the last index. If array of I is like less than, okay, array of I, if array of I, okay, is less than stack dot top element, okay, then we have to do st dot pop. That means here to remove all those elements from the stack. Okay, meaning that if this particular array, okay, or array of I is like less than or equal to, okay, less than or equal to, that means here I'm saying that, so for the index 3, okay, so this is 4, is this 4 is like less than this particular element at the top of the stack, so it will know. If it will be like yes, then we have to just simply pop out from the stack. Okay, then after that what we have to do, once it will be done, again we have to do these things, like if my stack is not empty, then we have to simply store our result in our vector, which is like our answer of I is equal to, we have to store our top element. Okay, if it will not be there, so yeah, like that. And then after that what we will do, here we have to do answer of I is equal to st dot top, and then after that I have to come out from the loop, and here to just simply define st dot push. I need to simply store array of I element. Okay, and at the last we have to simply return our result, okay, or answer. So let me compile and run. Okay, so here I'm getting I was not declared in the scope, where I'm talking, where it is talking about 9. Okay, answer of I. I was not declared in this scope. minus 1, I is less than or equal to 0, and then I minus minus. Very strong, everything is fine. What is wrong here? Again I'm going to recheck here. So int dot size, I have taken the vector of this thing, stack int st, okay, point I is equal to n minus 1, okay, and then I is greater than or equal to 0, then I minus minus, then again stack dot push, I have taken all those stack element in the stack, then after that point I is equal to again n minus 1, I is greater than again 0, and then I minus minus, okay, then again here while stack is not empty and array of I is like less than stack dot top element, then here I have to just simply stack dot pop. If stack is empty, okay, not empty, then here you have to just simply store it in a vector. That means answer of I is equal to stack dot top value, have to store it inside the answer value. Okay, then after that we have to simply return stack dot push array of I, then simply return answer. Let me try to compile again and run. Error is like I was not declared in this scope. I was not declared. Okay, so here I'm not defining as int. Okay, not defining the data type. Okay, that's the biggest mistake. Okay, and serial mistake, type of serial mistake. Let me try to compile again. Okay, so again I'm getting mistake here. And what? Okay, so second mistake will like this thing. Our array of I must be like greater than or equal to stack dot top element. Let me try to compile and run again. Yeah, its comparison is completed. So basically what here is saying, what I'm like to try to say here, basically first in the first step we have to traverse inside the array from the last, okay, and we have to simply store it in the stack. Okay, so like here we have to just like 4 2 3 1, here we have to traverse it like in this fashion, and we have to simply store it in the stack also like in this way, like 4 then 2 then 3 and then 1. Then in the second step we have to create again here we have to again traverse in the same fashion, but here I'm going to check inside the stack. Okay, so if stack is not empty, and the second condition is like that, if stack dot top is like, if array of I is like greater than, that means this element, I'm talking about this element, if 4 is greater than 1, that means yeah, it is true. So yeah, if it is like greater than top element, then we have to simply stack dot pop out. So here we have to pop out our 1 from this stack. Okay, then again talking about 2, is 2 is like greater than 3? No, so we don't have to pop out. Okay, and so for that value we have to just simply store it our answer of I. That means for the current value, for the current index, we get the greatest integer value, or we can say that greatest next greater element, okay, which we have to store into a vector, and then simply we have to store it inside by using stack dot push array of I. Okay, whatever I am getting here in the inside the vector here, and we have to just simply return our answer. Let me try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.